Hello, this is the Missouri University of Science and Technology ACI Student Chapter, and this is our submission for the Spring 2021 Concrete Solutions Competition. Our topic is innovative solutions and future research that is relevant to both students and industry at large. We will be focusing on the use and study of nanoparticles in concrete. Our discussion will include a background of nanoparticle use, solutions to industry problems, environmental effects, and relevancy to students.
So let's start first with the overall problem, one of the big problems with concrete. So the process of making concrete emits a lot of carbon dioxide, which has a negative impact on our environment. It's said that concrete contributes about 8% of CO2 emissions annually, which isn't a great percentage. This fact combined with the fact that concrete degrades quickly and has to be replaced, and that the need for concrete is rising due to a need for more infrastructure. In total, all of this means that it's only going to be more difficult in the future to reduce our environmental impact from concrete on the concrete side. So for this reason, it's become more and more important to look at sustainable concrete and what we can do to make more sustainable concrete. Concrete that lasts longer or has superior properties compared to what we conventionally make. One possible solution to this is to incorporate nanotechnology into our concrete mixes. So using nanomaterials or nanostructures, those can be added to concrete to hopefully enhance the properties and increase sustainability. So they could essentially be part of the future of concrete and how we see and design concrete on the whole.
So, general and industry solutions. Nanoparticles present a solution to failing infrastructure and high maintenance costs. Our current infrastructure is unsustainable as it requires maintenance and sometimes replacement, which costs billions of dollars over an extended period of time. One way to make infrastructure more sustainable is by using nanoparticles. Nanoparticles increase durability and allow for greater lifespans. This means less maintenance and replacement costs in the future. So some examples of nanoparticles that have high mechanical properties are nanosilica, nanoalumina, carbon nanotubes, graphene, and graphene oxide. Today, the example we'll focus on is carbon nanotubes. The image pictured here is a generation of what a carbon nanotube might look like. It's a very thin and slender tube constructed of carbon molecules. So carbon nanotubes mixed throughout a concrete structure provide greater strength and lessen the need for other types of reinforcement, such as bars or fibers. These nanoparticles reduce cracks and extend life cycles, meaning infrastructure could survive more wear for longer periods of time. Carbon nanotubes also possess electrical properties that could be used for strain sensing systems. In other words, these are systems that can detect cracks and strains and other issues affecting the structure that might not be able to be seen. And the picture here is actually of a new pedestrian bridge that was installed at our university. It's a perfect example of a structure that will experience wear, stress, and strain over its lifetime. Carbon nanotubes or other nanoparticles with future research could lengthen the life of similar bridges, reducing costs for both the university and city.
When it comes to environmental effects, titanium dioxide and other nanomaterials present a great benefit. Titanium dioxide can be an important nanomaterial used in photovoltaic concrete to have self-cleaning and air purification characteristics. This type of concrete can effectively cause degradation of typical pollutants found from industrial and automobile emissions. The downside, of course, is reduced purification efficiency over time due to carbonation. Utilizing the combination of self-healing materials and the added strength of many nanomaterials when added to cement can effectively lower CO2 emissions by replacing traditional OPC materials.
In terms of relevancy to students, two key areas were considered: the exposure to green building practices and research and development opportunities. For exposure to green building practices, emphasis can be placed upon reducing our CO2 footprint over methods previously discussed, reducing our construction waste. One, can be reduced from the longer lifespans of the material itself, and as well as self-healing characteristics within the property from the nanomaterials. Alternative materials, the nanomaterials itself mixed with other SCMs can replace the cement in the concrete mix, thus reducing the amount of CO2 our footprint will have. Additionally, research and development opportunities are being considered by professors and graduate students alike to increase the lifespan, the durability, and the strength of the concretes that we are producing today.
In conclusion, nanoparticles present a solution to industry and environmental concerns, as well as being an important area for future research. Both students of today and the industry workers of tomorrow will benefit from nanotechnology in concrete. This has been the Missouri University of Science and Technology team and our submission for the Spring 2021 competition. Thank you for watching.